Welcome to the lesson on training a static malware detector. In this lesson, we are going to construct a malware detector from beginning all the way to the end. The steps we're going to take are as follows. First, we're going to train, test, split our data. Since the data is going to consist of PE files, we're going to utilize this to our advantage by featurizing the PE headers. We are also going to extract n-grams and featurize these. Then we're going to train our classifier, and finally we're going to get an indicator of its performance by testing it. Now, one thing to note is that in machine learning, we are never truly done. You can always iterate and improve any of the steps in the pipeline. You can add more data, clean the data, you can add more features, combine features, remove features. You can try different classifiers, and you can also try different parameters. So it's important to know what your goals are and what your stopping point is. First thing we're going to do is specify the folders that are containing our samples. We're also going to create a label, labeling all benigns as 0 and malicious files as 1s. Next, we're going to use scikit-learn's module for train, test, splitting our data. The next step in our plan was to featurize all of our data. To that end, we're going to utilize all the various functions we learned about in earlier lessons. We're going to extract n-grams, we're going to get the imports from the PE header, we're going to get the number of sections and also the names of the sections. And then on these text features, we're going to employ our simple NLP recipe. Our feature selection for n-grams will be by frequency, and once we have our most frequent n-grams, we're going to use those as our features for the individual files. We then loop through all the files and featurize them. Files whose PE headers are malformed, we're going to skip. We create some pipelines in order to perform our text processing. And once we have all the individual features, we're going to stack them all together into one large feature vector. The classifier of choice will be random forest. It's not necessarily the best one, but it should be a pretty reasonable choice. Perhaps second best only to XGBoost. Having trained all of our various pipelines and classifier on the data, we can now run all of it again to extract features for our testing data and then test our classifier. In the next few lessons, we are going to discuss some more tricky machine learning situations, such as an imbalanced dataset or customer imposed constraints, such as a false positive constraint.